Hello everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is maximum frequency of an element after performing operations part 2. Now we have solved the part 1 of this problem yesterday, and that was a medium level of problem, and today's problem is hard. Basically, the problem is exactly the same, but the only change is there in the constraint. The constraint says that now the number inside the nums array can be up to 10 is to power 9, and the value of k can be up to 10 is to power 9. Yesterday, the number was in the part 1, the number was at max 10 is to power 5. So now if you try to solve it with the yesterday's solution or the part 1 solution of this problem, then it will give you memory limit exceeded error. I tried this, I got the memory limit exceeded issue. But no worries, we are going to solve it in such a way that we are able to pass all the test cases. So let's go through the problem a bit. In this problem, we are given an integer array nums, right? And two more inputs, k and or number of operations. The problem says that we have to perform number of operations times operation. That is, whatever is the num operation given, that many times we have to perform operation on the array nums, and in each operation we have to choose a particular data from the array which was not chosen previously. It means you can perform an operation on a particular element of the array once, and the operation is to add an integer within the range of -k to +k to your number. That's it. Now what you have to find is you have to return the maximum possible frequency of any element in the nums after performing the operation. So basically you have to maximize the frequency of any possible element in your array, and you have to return that value. For example, in this example number 1, the number says 145, k is 1, and the number of operations allowed are 2. So you can perform two operations on two unique data, 1, 4 or 5. You can choose any two data. You can perform the operation one by one, and in the operation you have to choose an element and either add any element from -1 to +1, because the value of k is 1. So what we can do is we can actually add 1 to 4. So this will become 155. So now the maximum frequency we have is 2. We have 1, we have 5, we have 5, right? So we have the frequency of 5 as 2. And now we have one more operation left. We cannot make the other element equal to 5 to increase the frequency in our array. So we can just say add 0 to any element. Let's add 0 to this 5. And now our final array is going to be 155. The max frequency is 5, which is 2 times. So the output is 2. Basically, we have to return the frequency, not the element which is going to have the max frequency. All right. So now let us see how we can solve the problem, and we are going to understand the solution approach using this particular example in which the elements are 159. The value of k is 3, and the number of operations allowed are 2. Now the first thing is, let's solve this step by step. Don't focus on this particular area as of now. The first thing which you need to focus is, if you have an element 1 and you perform an operation on the element 1, then what can happen? Or if you perform the operation on element 5, what can happen? And if you perform the operation on element 9, what can happen? Our target is to make sure that we have to convert these numbers into such numbers such that the frequency of any element in this array can be maximum, right? So we need to focus on the frequency of any element. Now, if I perform the operation on 1, this particular data, if I perform the operation, then what is the operation we can perform? We can actually add or subtract any element from the range of -3 to +3, right, in our element. Now, if I add 3 to 1, we will have 4. And if I subtract 3 from 1, we are going to have -2. So it means that we can convert our number 1 to any other number within the range of -2 to 4. You cannot convert this number 1 to any other number outside of this range of -2 to 4. You cannot convert 1 to 5, right? 1 cannot become 5, but 1 can become a max of 4 and a minimum of -2. Similarly, 5 can become a max of 8 by adding 3 to it and a minimum of 2 by subtracting 3 to it. Now this is a range. We have a range that I can convert 1 to -2 to 4. I can convert 5 to 2 to 8, and I can convert my number 9, which is in my array, to any other number which is within the range of 6 to 12. 9 minus 3 will be 6, 9 plus 3 will be 12. So that's our range of number within which I can convert my 9 to. Now, let's go back and focus on the fact that we have to maximize the frequency of any element. Now, I want to convert my elements 159 in such a way that after converting, I am getting a number which has a max frequency, right? All right, let's focus on this particular data, that I can convert my 1 to this particular range, I can convert my 5 to this range, and I can convert my 9 to this range. So this is my first range, this is my second range, and this is my third range of number. Basically, we are going to have or max to max 3 numbers, right? We are having 3 numbers, 1, 5, and 9. So we can convert it back to some other number. And the number of operations we are allowed is only 2. We cannot just convert all the numbers to some other numbers, because we can just select 2 numbers and we can convert it back to some other number. Again, our focus will be to maximize the frequency of any element. Now, first of all, we are going to have a sorted data. The data will be sorted. We are going to sort it. The data is not going to be input as a sorted data, but we are going to sort it. And I will tell you why we are going to sort it. But first of all, focus on the fact that we have 1, 5, and 9 all are sorted. And this is our range, right? 1 can be converted to this range. This is 5 and this is 9. Now, if I say that I am targeting the number 3 and I am saying that I want to convert all my numbers or maximum of my numbers to the element 3. So what are the numbers you can convert to 3? You can convert 1 to 3 because 3 is within this range. You can convert 5 to 3 because 3 is within this range. So for 3, you have two numbers which can become 3. You have 1 which can become 3. We have 5 which can become 3, right? So I know that I can convert my 1 and 5 to 3. So one of the frequency can be 2. 2 can be the best answer for this problem where the input is 159, the value of k is 3 and the number of operations is 2, right? Now, how can you find the best possible answer? We have one of the answer which is 2, but what's the best possible answer for this particular problem? Now, one of the way to find this is, let's forget about programming. One of the way to find is overlapping. This is one range, this is another range, and this is another range. All these three ranges are overlapping a max of 2 times. It is overlapping in this particular range, right? The first and the second range is overlapping with 2, 3, and 4. We have 2, we have 3, we have 4. If I consider 5, this particular number which has a range of 2 to 8 can be converted to 5, but other numbers 1 and 9 cannot be converted to 5. If I talk about 6, then this can be converted to 6, this can be converted to 6. So the max frequency we have is 2, right? Any element, if you want to convert it to some other element, you can have a max frequency of 2. Once we have this range created, we can get the same answer by overlapping these range. The first and the second range overlap, the second and the third range overlap, but all the three range are not overlapping, right? So the max answer we are going to have is 2. Now, we cannot just find the answer by overlapping, but this is giving us a good idea that what are the numbers we can select which can be the candidate which is going to have the max frequency. The numbers can be the overlapping numbers. See, the thing is, if I try to find out, see, I know that the answer is 2, right? The answer for this problem is 2, and we have multiple numbers which can have a frequency of 2. We can apply the operation in such a way. We can have 3, like we can convert 1 and 5 to 3. We can also have 2 as well. We can convert the 1 to 2 and 5 to 2 and still get the frequency as 2, right? Now, it is all about the overlapping numbers. If I try to find out a number which is not overlapping, such as 5, I cannot convert 1 to 5. I cannot convert 9 to 5. I just have one number which is equal to 5. So I have 5, which is one number of times. So the frequency is 1, but we have a better answer of frequency equal to 2. That is because if I focus on the element 5, this is the 5. It is not lying in this particular range. It is not in this particular range. It is just in one of the range. So the frequency of 5 is going to be 1, and we are going to have a maximum answer of 1 if we consider our target as 5. That 5 is going to have the max frequency. So we just need to focus on the overlapping range. Now, if you focus on the overlapping range, you have a range of numbers. In the first and second range, you have 2, 3, and 4. Here we have 2, 3, and 4, which is going to overlap. But we just need to worry about the boundaries. Because if we just worry about the boundaries, we are still going to get the answer, but we will not be processing a lot of data. For example, I know that 1 can be converted to any number between this range, 5 can be converted to any number within this range, and 9 can be converted to any number within this range. I have to focus on all the numbers within this range, right? But if I just focus on the boundaries as well, then also I am going to get the answer, and that is because let's consider a scenario where we have a number 3. Now 3 is not a boundary, right? But I know that I can convert my 1 and 5 to 3 because 3 is within both these range. So the frequency of 3 can be 2. Now, if we have 3, which is not a boundary, but it can be, it can be, I would say, a candidate which can have a max frequency. So let's say this is 3 and this is 3. Now try to focus on this. I am saying that you just need to worry about the boundary elements. You need to target the boundary elements and maximize their frequencies instead of targeting a ranged element. Right now, I am targeting an element which is within a range. Let us say that is 3, right? Now, if 3 is 2 times, then definitely, since this 3 is within a boundary, then it is going to have a bigger element, which is 4. And since this 3 is here, it is going to have a smaller element, which is 2, right? So they are going to collapse at the boundary as well. They are going to overlap at the boundary as well, apart from this range. So there is definitely going to be an overlap at the boundary, but if we just consider the boundary elements and ignore the ranged elements, the element which is within the range, then we will have a limited number of data which we need to search for and get the answer. If I consider all the numbers within this range, then the number of data will be very large. But if I just consider the numbers which is the boundary, then for every data, for 1 we have 2 more options, -2 and 4. For 5 we have 2 more options, and for 9 we have 2 more options, right? So these are all the numbers we will check for, that these numbers can have the max frequency. So what we are going to do is, once we receive an input, which is, I would say, from 1 to like 1, 5, and 9, we are going to find out what are the boundary elements apart from the elements itself. So we have 1, then -2 and 4, 5, 2 and 8, 9, 6 and 12. These are our potential targets which can have the max frequency. So what we are going to do is we are going to try to see how many elements we have in this array which can be converted to my candidates. For example, my candidates are -2, this is -2, then we have 1, then we have 2, then we have 4, then we have 5, then we have 6, we have 6 here, then we have 8, 9 and 12, so we have 9 and 12. So these are all our candidates, right? Now, once we know that these are all our candidates, we will try with each of these candidates that they are going to have the max frequency after performing 2 operations. So let's try to do it for, let us say, 5. Now, if I try to do it for 5, what do we need to do exactly? See, the thing is, we have 1 number of times initially, 5 1 number of times, and 9 1 number of times. I need to find out, apart from 5, how many elements do we have which can be converted to 5. So if I talk about the least number which can be converted to 5, that will be 2, right? If we have a 2 here, then we can say that we can convert that 2 to 5. And what's the max number which can be converted to 5? It is going to be 8. So we have to find out how many elements do we have within the range of 2 to 8 in our array. This is our array. This is our original data. So we are going to sort this, and what we can do is we can use the binary search. Basically, using Python, we can use the bisect module directly, but logically we are going to use the binary search, and we are going to find out what's the index where I can keep this 2 to keep the data sorted. What this will tell me is the leftmost index which is going to have the element 2, or right? And what about 8? We are going to put the 8 in this array such that the 8 is sorted, the data is still sorted. So we can put the 2 here and we can put the 8 here. So between this range we have got one element, right? So we got one element which can be converted to 5, and the number is 5 itself. But we should actually ignore the number if it is actually equal to 5. If we are searching for 5, we should ignore the 5, because we want other candidates which can be converted to 5. We have a count of 5 as 1, but what about the other candidates? So we have no more candidates which can be converted to 5. But what about 4? If I talk about 4, how many elements I can have in my data which can be converted to 4? So what's the leftmost range which can be converted to 4? It is going to be 1. 1 can be converted to 4, right? What about the rightmost range? It is going to be 7. 7 can also be converted to 4. Basically, that is because k is equal to 3, right? So I know that 4 can be created from a 1 and 4 can be created from a 7. So where should I keep this 1 in my array so that the data still remains sorted? So I will actually keep this 1. Let me draw it here. Let me just drag this data. Let me drag this data somewhere else so that I can show you. So I can keep this particular 1, the one which I have here, at this particular data, at this particular index, just before this 1. Still the data is going to be sorted. Now the thing is, I can keep the 1 here as well, but I want to keep it as left as possible to cover the maximum elements which can be converted back to 4. So I will keep my 1 at this particular data. What about the 7? Where should I keep my 7 so that the data still remains sorted? This should be this one, 7. Now, how many elements do we have within this range? We have 2 elements. We have 1 which can be converted to 4. We have 5 which can be converted to 4. So for 4, we have 2 candidates which can be converted back to 4. And the number of operations are allowed as 2 only, right? If the number of operations would have been 1, so although we have 2 candidates, we can just convert one of them to 4. So from here, what we understand is just find out this particular array and then find out what are the possible candidates and what are the elements which can be converted back to that particular candidate, and use the binary search to find out how many elements we have in between. That is going to be your answer. The maximum is going to be your answer for this. So let's actually try to solve this step by step. First of all, we are going to sort the data. So I would say it is going to be nums dot sort. Why we are sorting it? Because later on we have to use this binary search logic, right? And for binary search logic, we should have this numbers as sorted. If it is not sorted, then you will have to go through the entire data and try to find out, hey, what's the different number of data which can be converted back to your target. So we sort the data, and now let's create a counter of your data. That is, count how many elements you have or the frequency of each element. So for counter, I can say counter, counter of nums. Once we have done the counting, let's also store the store or create a set. I would say target is equal to set. Okay, these are all our target, all our potential target, right? Now, why I'm using a set? That is because maybe this target, these are all our targets we have. Maybe there is a collapse. So we are going to do the processing for a particular target multiple times, and let's not do it. And that is why I'm using a set. Now, once we have this target created, let's actually make it as targets, because we are going to have a multiple targets. Now let's go through our data for n in nums. We are going to store our target. So one of the possible target will be the number itself, the n itself, and the other target will be n minus k and n plus k, basically the boundary elements. For 1, we have a target of 1, and the boundary elements are -2 and 4. So we have a target of -2 and 4. So let's store the targets, other targets as well. I would say n minus k and n plus k. Now once we have all the targets stored, let's create a result variable which is for now 0. And let's go through all the targets and let us see which of this target can actually have the max frequency. So I can say for target in targets, the current frequency of the element is counter of target, right? This is the current frequency of the element. This is the number of times the element is right now in our array. Now let's find out the rightmost element which can become your target data, and the leftmost element which can become your target data. So the rightmost element is actually going to be equal to, let's use the bisect module for this. We can actually have this binary search logic, but we have a bisect module which can find out where should I keep my element such that the data still remains sorted, the rightmost point at which I can keep my element. So I can say bisect dot bisect right. We have to use a method called as bisect underscore right. In this we have to pass our array nums, and we have to pass our target. So the target is actually target plus k. This is the number, this is the rightmost number which can become target, because we can simply say this is our number. I would say we can perform the operation on this number, and the operation is going to be target plus k, that is our number. The operation is going to be to add the negative of k, and this will become back to target. So we can convert our target plus k to target, right? Now, what's the leftmost index which can become our target? Leftmost index at which I can keep my element, which can become back to target. So I can say bisect dot bisect. This time it will be bisect underscore left, and we have the nums array, and we have the target minus k. This is the leftmost element which can become back to target. So we got our rightmost index, we got our leftmost index. How many elements do we have in between? We basically, if I have this 7 here, 1 here, how many elements do I have in between? So this is at index number 0, this is at index number 3. No, I think this should not be at index number 3. 7 should not be index number 3. 7 should be index number 2, I would say, because we are just checking which index should we insert our element when we say bisect left or bisect right to keep it sorted. So if the original data is 159, we should keep the 1 at index number 0, and if the original data is 159, we should keep the 7 at index number 2. This is 0, this is 1, this is 2. So 7 is at index number 2, 1 is at index number 0. I could say 2 minus 0, that would be 2. That would give me how many elements do we have in between which can be converted back to our target. So I would say we have right minus left number of elements which can be converted back to target, right? But we should remove, which we can say minus frequency. That is because these are the frequency number of elements we already have, which is equal to target. So we should not try to change the target, which is already equal to target, back to target, right? If the number is 4, we are searching for 4. We should remove all those numbers within the range which is equal to 4 to find out what are the other numbers which can be converted back to target. So these are the number of elements which we can convert back to target. And now I can say result will be equal to max of result, or I could say frequency, the current frequency of my data, plus the other numbers which can be converted back to target. But we should make sure that these numbers are less than or equal to the number of operations allowed. We cannot convert numbers, like if this value is, let's say, 100, and the number of operations allowed is 4. So we cannot convert more numbers, more than num operations number of numbers, back to target, because we are just allowed num operations number of operations. So we have to ensure that this particular value doesn't exceeds the value of num of operations. So I could say minimum of num ops, comma, right minus left minus frequency, and we can just come out of the loop and return the value of result, submit this particular code. This is going to pass all the different test cases we have for this particular problem. Right now we got some error. Let's try to resolve the error. The error says that unsupported operands. Okay, I think there is some syntax error. Let's try to see what's that particular error. I think this is because the value of frequency is equal to counter of target. This counter should actually be a small case counter. The counter is the actual object here. So now this should be fine. Let's submit this. Let's wait for the result. And I think it should pass all the test cases. Let's just wait for the result. And I think, yes, it is accepted. If I just minimize this, you can see that the runtime is pretty good. The memory used is pretty good as well. And all the test cases are accepted as well. So we have solved this particular problem in a very efficient way. And guys, that's it for this video. If this video has helped you to solve the problem, understand the problem approach, how to solve it, and what's the trick behind solving it, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you do so. And I will see you guys in the next video. I want to see you guys in the next one. Thank you for watching this one.